Welcome back. Now that we know how to convert rectangular to polar, we're going to look at some polar equations and we're going to convert them back to rectangular. Granted, via the videos, we haven't seen what these polar equations look like. It's hard to kind of comprehend that, but right now we're just going to focus on our converting. Okay? So we still have our three rules that we know, x, y, and r. Okay? What we're going to have to do is we're going to do some algebra maybe to mix these up, rewrite them, whatever we need to make this conversion. So this first one, we have r equals -3 cosecant theta. Well, since we don't know anything about cosecant, I'm going to rewrite that as a sine. So this becomes r equals -3 over the sine of theta. Okay? What I'm going to do here is some algebra. This is r over 1. I'm going to go ahead and cross multiply. So I end up getting r times the sine of theta equals -3. You can see why I'd want to do that because I know that r sine of theta is y. So this just translates to y equals -3. This is just a horizontal line at -3. That's it. Okay. Not too bad on that one. So here, I have r equals to cosine theta. I know that r cosine theta is x, but the only way I'm going to get that is if I were to multiply this by r. If I multiply one side by r, I have to multiply the other side by r. So that's what I'm going to do. I can do that because, again, if you multiply one side, you multiply the other, you're not changing the function. It's okay. It's allowed. So r squared equals 2r cosine theta. Well, I know what r squared equals. R squared equals x squared plus y squared. So I'm going to make that substitution. And I know r cosine theta is x. Normally, we are used to seeing our functions in terms of y. Y equals blah, 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 right? But here, since we have x's and y's, that might not necessarily happen. These might not be functions that we're used to seeing. They might be more like relations. This is going to end up giving us a type of circle. We could rewrite it, do some algebra, but at this point, it is technically a rectangular equation. It's only in terms of x's and y's. We're going to call this good for now. Okay? So once I've eliminated my r's and my thetas, I'm good to go. So we're done. Next problem. Again, we have a cosine and a sine, but we're missing that radius. So what I'm going to do is similar to what I did on this first problem. I'm going to do some cross multiplying here. That's going to end up giving me 2r cosine theta minus 3r sine theta equals 6. Well, that's pretty simple because now I know r cosine theta is x, r sine theta is y, and now I'm in my rectangular equation. Again, for example, we're used to seeing y equals. So I could go ahead and minus my 2x over. So -3y equals -2x plus 6. Divide by -3. So y equals 2/3 x minus 2. And I'm just looking at a line with a slope of 2/3 and a y-intercept of -2. So it's just making those substitutions, finding my r sine, my r cosine, or my r squareds so we can substitute and solve. Okay, that's it. If you got questions, let me know.